Hi, everyone, and welcome, and thank you for joining today's webcast, Enabling Analytics with R and Microsoft BI. My name is Matt, and I'm joined today with my colleague Scott, who are both Business Intelligence and Analytics Consultants at Thorogood. So before we jump into the agenda for today, I always like covering off kind of the objectives so that we can make sure that we're sticking to what we have planned to cover in today's webcast. So the first objective that we have today is to discuss Thorogood's approach to analytics and outline how this model can enable analytics within your business. The next objective that we have today is to explore the key benefits of combining Microsoft BI and R in analytics projects and to show some of those pairings in action. So now for our agenda for the day, we're going to do a bit of an introduction both to Thorogood as well as some of the technologies that we'll cover today. And then we're going to talk a bit more about our approach to analytics, as I mentioned on the previous slide. Following that, we're going to get into our demos, and we're going to show a couple different ways in which you can pair Microsoft BI with R. And then finally, we'll talk about some considerations for getting started, either with these pairings or with analytics projects in general. So a bit more about Thorogood. We're an independent professional services firm specializing in business intelligence and analytics. And we've been specialists in this space for about 30 years. We serve our customers globally across all of our offices listed on the screen. And all of our consultants are recruited and trained in the same way. At the bottom of the slide, I have a couple of the services that we offer. This covers the end-to-end life cycle of really any business intelligence or analytics project, starting with initial strategy, through to requirements gathering, design and implementation, following on to training and support of business users and the user community. We also provide ongoing data or analytics services, as well as planning and business modeling. So the customers we work with typically span 4 data-rich verticals. Those are consumer goods, pharmaceutical and health services, retail banking and capital markets, and insurance. And we work with customers across the board on various business intelligence and analytics needs. Now, on the other side, we have the technologies that we work with. And as I mentioned, we are independent, so we don't work with any one specific technology. Rather, we do partner with a wide array of technologies based on our customers' needs. This includes back-end tools, front-end tools, as well as more analytically driven technologies. And so our key focus for today is on Microsoft. So I'm going to talk a bit more about that partnership, and then I'll talk a bit more about R. So in terms of our partnership with Microsoft, we've been a gold partner for over 10 years, and we are certified in data analytics and BI solutions. In addition, we are a cloud platform certified partner. Our partnership gives us a really unique interface into the Microsoft development team, and this allows us to gain insights into the Microsoft product roadmap. It also allows us to work with customers to help shape and give feedback to key Microsoft initiatives. We're part of a number of different programs that I've listed on the screen. Specifically, the one that I wanted to call out is the Business Intelligence and Advanced Analytics Partner Advisory Council, or the BI PAC. And if you're interested in working with working with us on any of these initiatives, please don't hesitate to reach out. So now a bit more about R, because it's obviously one of the tools that we're going to be covering today. So R is an open source statistical programming language that was developed in academia actually 25 years ago. Because it's open source, the kind of aptitude and appetite for R has grown through a number of different contributions through the very large community, primarily through academics and statisticians, but also really anyone, be it data enthusiasts or data scientists at different organizations. And this community has kind of fueled the growth of R through building various R packages. And these packages contain different models and libraries that are available to the public. More recently, R has become enterprise-friendly with companies like Revolution Analytics, who have created enterprise tools that help leverage the statistical power of R in a more enterprise-ready way. Revolution Analytics was actually purchased by Microsoft several years ago in 2015, and that's really what's kind of outlaid the roadmap for a lot of what we're covering today. And since then, Microsoft has invested in the integration of R into its BI stack in many different ways, some of which we'll see today. So now that we've done a brief introduction of Thorogood as well as the technologies that we're going to cover today, I'm going to turn it over to Scott, who's going to talk more about our approach to analytics.
Thanks, Matt. So at Thorogood, we base our approach to analytics on the cross-industry standard process for data mining. And this is pretty similar to our general approach to business intelligence in that it drives business value by taking the business goals and coupling them with technical possibilities. So I'm going to walk through this approach from the perspective of an analyst. So when you're starting off an analytics project, as an analyst, I might leverage my own business understanding, and then I also might pair this with the knowledge of some subject matter experts from the business. And what we're looking to do is identify the questions that are difficult to answer, but the answers to those questions would provide a lot of value to the business. I also might reach out to some of my company's data experts so they could inform me how the existing data that we have could help to answer these questions. Then once I've identified the questions that I'm looking to answer and have located data that I can use to find the answers, I need to prepare the data in a way that will allow me to use it in my analytical models. So the data preparation and modeling phases often require a bunch of iterations back and forth. As my analytical model is tweaked and refined, then the format of the data going into that model will need to change as well. So I'll be iterating back and forth between those steps. And then coming out of that iteration, I'll want to evaluate the results of my model as well as the validity of the model itself to make sure that what I'm coming up with is really making sense for the business here. And then as I move into the evaluation phase, I'll be assessing the results, and during this phase, I'll use my business understanding and some of the data understanding that I gained at the beginning of the process to evaluate how well the model is actually answering the questions that I'm interested in. So here, I might determine that the data needs to be prepared slightly differently, or I want to adjust my model. Maybe I'll remove some outliers or add additional variables, and then I'll go back through and run my model again for further evaluation. And then after these iterations, eventually I'll come to a model that is giving me some insights that I think are really interesting and I want to share with the wider business and potentially run regularly. So at this point, I look to deploy the model for repeated use and analysis across a bunch of applications in my business or various reports or operational systems. So today we're going to explore 3 different ways in which the Microsoft BI stack and R can play a key role in this approach that I just walked through across data prep, modeling, evaluation, and deployment. And as we work through the approach, there are a couple pillars that we want to keep in mind that really serve as a foundation for the success of any analytics project. So the first one of these pillars is people. In an analytics project, there's a number of roles that need to be filled, and all these roles need to work together effectively to make the project successful. So I might have data scientists developing models and determining how the results should be interpreted. I might have some of the data experts from my business, informing me how I can be able to access this data, the format that the data is in. Depending on the organization, they might be doing some of the data preparation. And after I've developed the model, I'll also want to get in touch with them to sense check my use of the data in the model to make sure that I'm using it properly. And then I'll also want to be in touch with the experts from the business who, as I mentioned before, are formulating those valuable questions. They're providing the necessary business understanding to approach the problems, and then they'll be looking at the resulting models to evaluate how useful they are to the business. The second pillar that I want to consider is data. So the data understanding phase of the analytics approach is really crucial in determining if the organization has the proper data to answer these valuable business questions. And if my organization does, how are the data sources formatted? And if there is a variety of sources, how am I going to combine these? Or if I don't think I have enough data or the proper data, what type of external data could I look to help answer these questions? And of course, there's always considerations around data security and management to make sure that the analytics project that I'm running is following the standards that are upheld throughout the rest of the business. Then the third pillar that I want to talk about is tools. So some of the tools used during an analytics project, such as the Microsoft BI stack, are used really widely across the entire business and apply to a broad user base. But some other tools like R might be directed more at niche experts, so you wouldn't have everybody in the business familiar with or frequently using R. And because of that, it's important to have tools in your analytics project that are working really well together. And this would allow the insights that you're getting from the niche technologies like R to be boosted by the enterprise scalability of your heavily used BI tools like the Microsoft BI stack. Then lastly, since there's a lot of moving parts across these pillars, it's really important to tie all of the pillars together through the proper processes. So these processes could involve optimizing how the data analysts and data scientists request access to data. It could be facilitating effective communication across the subject matter experts in the business, those with the data understanding, those who understand the analytical models. I might want to manage sandbox environments for data experimentation, so I'm not, testing out models on my production data. And I might want to deploy the insights from these analytics projects out to the business and then tie this new data back to the source data so that for future projects used across the business or future reporting, they can also share these insights. Now that we've covered some of the conceptual aspects behind our approach to analytics, we're going to dive into some real-life opportunities for implementing these types of projects through the integration of Microsoft and R. So as Matt mentioned, Microsoft purchased Revolution Analytics in 2015, and since then, Microsoft has really expanded the possibilities for integrating R into Microsoft BI solutions. So first, I'm going to walk through the R products that are available from Microsoft. The first of these is Microsoft's R Open. So this R Open offering is a result of thorough testing of the core packages that are used very frequently in the R scripting language, as well as the optimization of some of the functions through enhanced math libraries. So R Open is free to download for everyone, and it doesn't require any code rewrite from your existing scripts written in open source R. So when you're trying to implement Microsoft R Open in your business, there's an extremely low barrier to entry. The next offering from Microsoft is R Server, and this is commercially supported by Microsoft. So this allows for fully scaled data sets and computations that can then be easily deployed across multiple platforms. It's available with Teradata, Hadoop, and SQL Server, which enables running these advanced analytical models on enterprise-scaled data sets. So there's something called Scale R, which applies parallel processing to a set of open source functions that are frequently used in R for data analysis. And the Scale R functions are unique from their open source counterparts, which means that there will be a little bit of code rewrite from your open source R scripts to use these Scale R functions, but it's still using the same syntax that R developers would be familiar with. And lastly, there's R Client from Microsoft. So again, this is free to download, and the Scale R functions are available in R Client. So this is focused on R development, and one thing to consider in R Client is that data is stored in memory when you're running it locally. So a common project lifecycle might be local development on the R Client and testing out and formulating your analytical models. But then when you want to scale out to your full enterprise data sets, which are going to be too big to run locally on your machine, you would run R Client on top of R Server. And this allows the full power of those parallel processing Scale R functions to be leveraged. And this is really native functionality using this common project lifecycle in our client, because our client has a flexible compute context, which means you can change this easily where the computations are actually running. So you can change it to our server and leverage the power of that server. Then on top of this suite of products, Microsoft has developed additional installations and native integrations to utilize the analytics power through the BI suite. So to begin, Power BI is Microsoft's rapidly developing BI reporting tool. It's already integrated with R, and that supports really rich visualizations of your R models. So these visualizations could be Power BI visualizations that are sourced with data from your R analyses, and they can also be visuals coming directly out of R. And the analytics-driven visuals are displayed on the same reports as your key business KPIs, so all your reporting needs are all located in one area. SQL Server R Services brings the analytics capability of R directly to your SQL Server. So now you can run all your statistical models directly on the data that you're already storing in SQL databases without the data or the results of the analysis ever leaving your server. And then if you also have existing R scripts, you can copy those directly into stored procedures in SQL and deploy those on your database, which makes the completion of analyses a ton more efficient, as well as it also increases the accessibility of the resulting data. Operationalization, which is previously known as Deploy R, is an integration service for incorporating R scripts into a web service. So the tool forms a bridge between the compute capabilities of our server and the analytics applications that you have in your business. So this expands the potential audience of your models that you've created. In most cases, the technology will receive inputs from an application. Then it will call our server based on the inputs and the R code stored in the repository, and then it delivers the outputs of the request so they can be read or viewed within the original analytics application. And then also in the web service space, Microsoft offers Azure ML, which is a platform that's very closely integrated with R. So the cloud-based machine learning service is used to build predictive analytics solutions. And inside Azure ML, there's an execute R script module, which means that you can, again, take your existing R scripts and copy them directly into your Azure ML workflows. So then you can read from and write to Azure ML with that existing R code. And there's also a bunch of the math libraries that are frequently used in R that are preloaded into Azure ML. But if there's libraries that you need that aren't preloaded, it also allows for loading in these additional libraries very easily. So based on the time constraints that we have for the webcast today, our focus is really going to be on Power BI, SQL Server, R services, and operationalization. And then to dive into these specific technologies and integrations with R, we're going to walk through 3 specific business needs. Utilizing the capabilities of Microsoft and R, we're going to demonstrate one possible solution to the analytics need. So we're going to start off with a reporting-focused demo of Power BI and R, and that's going to highlight how your business can benefit from the statistical modeling capabilities of R without really restructuring or customizing your data architecture. So if you're already doing reporting in Power BI, it will fit right in with that. So integrating R analytics into your reports with Power BI doesn't require any change to your back-end data structure. Within Power BI, users have the ability to synthesize data from a variety of sources, and then you can take all that data and structure it however you need to structure it for your reporting. But the great thing about the integration with R is that after your data is already in there, you can also add valuable visuals utilizing statistical modeling and analysis. And Power BI offers a user-friendly, interactive, and self-service environment, and in this environment, you can broadly share the results of these analyses. And then there's 2 built-in features that I had touched on before in Power BI that are great for integrating R. There's the R data connector and R script visuals. And to demonstrate really what these features can do, we're going to look at a specific business case. So I'm going to dive into a scenario. So there's a consumer packaged goods company that has an existing suite of reports, and the sales analysts and managers of the company frequently use those reports. And in these reports, there's a summary of past performance, but what we've really been focused on recently and what we'd like to learn a little bit more about is future predictions for some of this data. So to meet this need, we're going to use the R data connector, and then the connector enhances the data available for building visuals and creating reports in Power BI by importing the results of an R script. The data is then available in the Power BI workbook with the remainder of the data that I have in there, and I can transform, format, or blend it however I need. Then lastly, I'll use this data combined with the data that I have already in Power BI to build visuals directly in Power BI desktop. Then since all the data can be used just like any other data loaded into Power BI, it can be used for native or custom visuals, all with the same interactivity. Then the business also needs a way to analyze the immediate impacts of trade expenditures. The workbook that I have already shows the actual trade expenditure values, but some further analysis is needed to get the insights into the relationships between these outcomes. So the second feature that we're going to focus on in the integration of Power BI and R is the ability to add and interact with R visuals, like correlation matrices and radar charts. An R script visual uses data already available in the Power BI workbook as the input for an R script, resulting in a chart or graphic coming out of R. And this allows you to use the data that you already modeled in Power BI as the input for your analysis. So in short, there's a lot of potential for this workbook, and we're looking to really improve the workbook by integrating R. So as I said, I'm going to walk through a CPG workbook that we've created, and I'm going to explore some of the opportunities to enhance the workbook by taking advantage of this close integration of Microsoft and R. So I'm going to pull up the workbook here, and this is in Power BI Desktop, which is usually more targeted as at users that are actively authoring content within Power BI. So for general users who are more consuming the reports, the online tool from Power BI is great for sharing and collaborating. Then Power BI Desktop includes native connectors for importing data, data modeling, as well as visualization, construction, and report building. So on the next page of this report, I have information about my organization's retailer sellout values. And this report is really great because I can go across the top here, and I can select my different customer groups, and I can look at sellout values across those groups and over time. But as I mentioned, it's great to have this historical data, but I'd be interested in seeing what forecasts of this data would look like going into the future. So to do this, I'm going to go to the Get Data option. And like I mentioned, there's already a ton of data connectors built into Power BI. The one I'm going to focus on is the R script data connector. And when I click Connect, a little dialog box comes up where I have free text entry of any R script that I want to enter. So let's say that one of my analysts sends me just a text file of the R code that I should be implementing here. So I'm going to take this and I am going to copy it, and I can just paste it directly into the R script dialog box, click OK, and that's really all I need to do to incorporate that, that data coming out of that, that R analysis into my Power BI workbook. So that I can see my resulting table here, where I have these historical values on which I ran the analysis. I have the values, time period, and my actuals. And then I have some confidence intervals and some predicted values coming out of that. So I can click the Edit button, and came up over on the other screen. But this is where I can manipulate the data if I wanted to change columns or if I wanted to really do this manipulation within Power BI instead of doing it in R, I could also do that here. Since I already have this data loaded into Power BI, I am going to just close out of this dialog box. I've already brought this table in. And then I'm going to move on to this next sheet here, where you can see that I've incorporated the forecasted values as well as those confidence intervals into my retailer sellout values. So now I can have a sense for where my sellout values may be moving in the future. And then, like I mentioned before, in some instances, there's analysis completed within R scripts that's really not easily displayed in Power BI visuals. For these instances, we can use the R script visual integration of Power BI and R, which allows us to use the data that we've already loaded into Power BI, run some R script on that creates a visual, and actually display that visual similarly to as you would see if you were running it in R. So I move on to this next sheet here. We're using trade profit data to generate this correlation matrix here. So as I said, it syncs perfectly with all of the data that you already have in here. So you can see that I've brought in all these values for my correlation matrix. And then if I click on the visual itself and open up this R script editor at the bottom, this is the actual R script that's being run. There's a run button right here that is creating the visual, and this is what's creating my visualization right here. So the reason that's so great is if there's a quick change that I want to make, like let's say I want to get some actual numbers rather than these differently sized circles, then I can change method to number, click run here, and then you can see that the visual updates immediately. So even though it's running on the data in Power BI, the R script is really easy to change in case I want to adjust that visual. So in just these two examples, we loaded some data from R going into the forecast table and added this R visual, this correlation matrix here. And through that, we're able to see how the seamless integration of R and Power BI makes reporting a lot easier for analytics projects. And then the end user experience is also really familiar and intuitive. So if you've used Power BI before, you're really familiar with this interface. But now it's enriched with the power of R analyses. So to quickly recap what I just covered in that demo, in the specific business use case, we saw that integrating R with Power BI allowed us to enhance our existing sales figures and look a little bit into the future. Then with the R data connector, we generated and viewed some forecasted data, and then we used an R visual to allow us to explore and understand the relationships between expenditures and outcomes. So users can intuitively interact with previously complex data and efficiently spread insights to a wide audience by publishing the final reports through Power BI. And then to quickly touch on how this fits into this approach to analytics that we've been discussing during the webcast, there's a few ways to tie this back in. So for data prep, as I mentioned before, when the data is brought into Power BI, all of your data, the results of your R analyses and your original reporting data is all in one source together. So all the manipulations that you make can all be done together on that same data. So your data can be formatted together, which will be really good for reporting later. The R data connector and R script visuals really help with the modeling and evaluation phase. As far as the modeling, you can see your results almost immediately. So you can build your model in Power BI, or you can adjust your R script in there, and then you can see how it affects your model instantly when you're running it within Power BI, which can make evaluating the model much easier. Then lastly, we haven't touched on this too much during the webcast, but we also have a ton of videos and webcasts about this. Power BI workbooks can be shared extremely easily through Power BI Online. So this can make the deployment step of an analytics project using Power BI and R go very smoothly. So now I'm going to hand it over to Matt, who's going to talk a little bit about the SQL Server R services and show a demo for that.
Great. Thanks, Scott. So what we're going to talk about today, as Scott mentioned, is SQL Server R services, which is effectively the way in which R has been brought into SQL Server. So to talk about this, or at least to set the scene, I'm going to talk about really a pretty common situation that we've seen with some of our customers for people either using R, but really more generally using statistical technology and people who have that depth of understanding. So there are many companies who will have existing forecasting models such as forecasting or other R models such as clustering or distribution models in place that they use for a variety of different reasons. And the process, as we've seen, has often been pulling data from a source and then integrating it with the R models kind of outside of that original source. So, for example, if the source was SQL Server, they might have that source pull the data out, integrate it with R, perhaps in a tool like Excel, and then the results are likely shared, in many cases, over email. And all of this can be pretty time-consuming. It can be, in some cases, inaccurate or out of date based on the amount of time that it might take to put together the insights. And so what we're looking to do here, in particular with integrating R and SQL Server, is really to decrease any inefficiency and then decrease the amount of time and effort it would take and therefore increase the value. So specifically the way that works is that our services will allow you to keep all of the data within your SQL Server database, and as well as storing the R models in that database so that everything is together. Overall, there's less movement of data. The source and the output can be together, accessed with a single reporting tool. And again, this then means that you can really get at results and get at everything quicker. So to demonstrate this a bit further, I'm going to look at an insurance-based use case. So in this case, I'm going to specifically be looking at an insurance company that's receiving submissions with relevant information that's entered into their system. So what I mean here is that when they get a submission for a policy, in this case, if it's a car insurance company, they might get something like the vehicle type, the age of the vehicle, the driver information, maybe other information, other attributes of that individual. So this submission, in the case of this example, is going to be stored in SQL Server for some analysis prior to it being approved, in which case it'll become like a fully blown policy. Typically, before we're leveraging our services, this information will be pulled out of SQL Server, pulled out of our transactional system, and then there'd be some analysis that would take place, and then they'd put the results back into SQL Server. With our services, what we're going to look to do is actually take those unscored submissions, apply our model directly in SQL Server using our services, and then pick up the scored submissions in the same database. And so these three steps, I'm not going to walk through them in detail in the demo, but I did want to outline them here just to illustrate the fact that this is all going to be maintained in SQL Server, different components leveraging different aspects of R. And for those of you guys who have very good vision, you'll notice that on the left-hand side where we have unscored submissions versus the right-hand side where we have scored submissions, those are really going to be the same thing, save for some additional columns that will enrich our data via the R script in the middle of the screen. And that R script will be executed via a stored procedure. So I'm just going to jump into the demo here. All right. And so this demo here is, as I mentioned, we're leveraging a stored procedure in the background. And for the sake of just demonstrating the capability, we've actually built it into an SSRS report or SQL Server Reporting Service is Microsoft's Pixel Perfect reporting tool. So what we have here is we have a series of new submissions that are unscored with just the submission ID and several attributes about the submission. A couple of visualizations just to show how our scored submissions are lining out relative to each other. And then really the most important part here is these predicted values that are associated with our now scored submissions, i.e. what we've run our model against and gotten our predicted results. And again, this is going to be based off of stored procedures. So for those of you who are familiar with the Microsoft BI stack, you'll think about ways in which you can use this stored procedure really in a variety of different ways, whether it be through an SSRS report like I'm about to show, or perhaps extended to an SSIS package, integration services, or perhaps even further extending it to different jobs like SQL agent to call it whenever a submission might come in. So what I'm going to do here is I'm going to score a submission. In this case, I'm going to pick up the submission ending in 1.5. I'll just come down here, grab that submission. I've set the report to score, and I'll hit view the report. So while this runs, what the report is doing in the background is it's calling the stored procedure, sending the submission ID with the associated attributes, and then scoring it so that it's now marked as scored and we have those predicted values. So now once I've scored the submission, if I hit view the report, we'll notice that this submission here will now disappear from the top, and we'll now be able to find it on the bottom. Let's see, it's down here at the bottom. So now this scored submission will come in with the predicted frequency of a claim, the predicted severity of that claim, and the predicted pure premium based on the attributes that we've inputted for our model here. So that concludes that demo. We gave an example of how we can integrate an R model via stored procedure into our Microsoft SQL Server Reporting Services report. So as we saw here, that SQL Server R Services increases the efficiency of analytical models and accessibility of the predicted score results for underwriters or really anyone in the organization to see. The ability to run these models on a schedule or on demand, like we saw in the report, will allow really anyone to tap into this information when they so choose. So to tie this back to our model for our approach to analytics, the first bit here, I mentioned a couple different ETL tools and components. With all the data integrated into SQL Server, you really have the flexibility to prep the data in any way that you wish, whether it be through a tool like SSIS or using things like stored procedures and bringing all of that together. We also saw that we could use SQL Server R Services to run models on our database, so to help with that modeling and evaluation phase. And then lastly, we saw that you can really deploy these models and leverage them in a variety of different ways. In our case, we showed it in SQL Server Reporting Services, but I mentioned you can use it in a variety of different ways, whether it be through an operational system like SQL Agent or something like SSIS. So now with that, I'm going to move over to our last demo, Flexible Analytics with Operationalization. So Microsoft will sometimes refer to operationalization as the R integration server. And what we mean by that is that operationalization really lets you pull together an R model and then use it and leverage it in a variety of different ways across a variety of different data sets and platforms. So the way that this works is that it actually creates a web service architecture hosting the R code. There are multiple options for input at that point. Important to note that no data is actually stored on the operationalization server. It's just the R code. So with that in mind, you can really input information in a variety of different ways, whether it be through data files, user input fields, or even other web applications. And with that in mind, really the outputs are very highly customizable. So you can leverage things like R visuals, which we'll see in a moment, web visuals, perhaps like D3, or even other reporting tools that can leverage web services, tools like Tableau. So in this case, we're actually going to use this, for this demo, we're going to use the same model. However, the use case is going to be slightly different. In this case, we want to provide underwriters with flexible access to predictive scoring for hypothetical situations. So the key difference here with the prior demonstration that I showed is that this is all going to be hypothetical, sort of what-if analysis. We aren't going to be scoring actual submissions we've received into a database. We're going to be leveraging a model in which the users, the analysts, can come in and say, you know, what if my driver is driving this car? What if they're this age? And then they'll get a sense of where those predicted values will fall to help with analysis. And the way this is going to work very simply is that we're going to have a custom application, in this case a website, and then on the other side we're going to have our operationalization web service. Now you'll notice here that I've featured a deploy R kind of interface or module, and Scott mentioned operationalization is really the next iteration of deploy R. And in this case, we aren't going to get into it in detail, but operationalization doesn't yet have a graphic interface for you to load in your R scripts. It's really all done through something similar to a command prompt. We would expect there to be a graphic back-end interface, but for those of you who are using deploy R or interested in either the operationalization or deploy R, I'd urge you guys to reach out to understand how the two kind of interplay and how one might progress from using deploy R to operationalization. So once we have our custom application set up and the operationalization web service, those two components are going to communicate via call and response. And so with that, I'll just jump into the demonstration to show it in action. Great. So this is my website, very simple website, again, leveraging the model in the back end of what we showed in the previous demonstration. So essentially what I have here is a variety of different attributes of a driver that will give out a predicted frequency, severity, and pure premium. So the way that this works is I have a series of drop-downs. Again, these are what the inputs that our model is trained for, and I can come in and select any of those inputs. So if I select hatchback, vehicle age is 3 to 6 years, the driver area is B, and then the driver age is 41 to 50, if I hit go, those inputs will be sent to my web service, and then the results will come back. And what I'm shown here is a series of consistent visuals that are highlighting where, based on my inputs, the driver is falling. So you'll see that, for example, here they're kind of in the middle of the pack in terms of the frequency of a claim for that car type of a hatchback. And so you can kind of get the idea that any inputs we have here will get back the scores. And again, what's important to note here is that because this is a web service, it can be leveraged in a variety of different ways. It doesn't need to be a website. It can be fed into other applications. There can be a series of different web services that will communicate to give you results of the R models. So now I'll jump back into our slides to wrap up. So to recap, operationalization provides a platform that's highly customizable for analytics integration. We talked about a couple of the business goals here around quickly evaluating insurance pricing, as well as those technology capabilities of really leveraging the web service in any way that you see fit. So to tie this back into our model here for analytics, really where we see this coming into play is really in that last leg, the deploying of R models that can be leveraged across a variety of different applications. So we wouldn't expect people to necessarily be evaluating our models using this tool. Rather, we would expect them to be confident in the R model that they want to deploy, set it up in a tool like operationalization or a prior version like deploy R, and then leverage that in a variety of different platforms, whether it be websites or applications or other reporting tools. So we've covered quite a bit today, and we are a bit tight on time, so I'm just going to run through a couple considerations for getting started before we wrap. So to highlight some of the considerations for getting started, we thought it would be worth noting some of the common obstacles that people will face, as well as some of the ways that we approached kind of facing those obstacles. So we have a couple different items here. I'm really only going to touch on a few. If any of these resonate with you as you read through them, please don't hesitate to reach out. So the first one I'm going to hit quickly is the one to the far left. And really this is pretty fundamental to getting started and being successful with analytics-driven initiatives. And what we have here is in which you or a group is struggling to identify or get buy-in for value-add business questions. And what we'll recommend doing in this case is to conduct what we call a visioning session, in which you can come together and brainstorm analytics opportunities with business and technology stakeholders. And we feel that bringing everyone to the table up front to get a shared understanding really helps drive to success, because everyone leaves that with an understanding of, everyone will leave that session, with an understanding of what the value is going to be, how we want to achieve it, what are the key goals, and what are the technologies that we're looking to use. A couple over, so the third one over, the other one that is the other one I want to call out, and that one specifically is untangling data scientists' complex models, which makes deployment a massive challenge. And what we'll look to do here is to work with customers to establish a strategy for analytics, building off of our general approach to analytics in the ways that make the most sense for our customers. And in this case, what we see is key here is identifying proper ownership and best practices for building effective analytics models, ensuring that people like data scientists as well as analysts and strategists can all work together to make sure that the proper technologies are being used and leveraged in a way that is the most effective in driving the most value. So again, if any of these particular challenges or obstacles reach out to you, resonate with you, please reach out. We'd love to hear more about them. Anything that we hear from our customers is always valuable to us to understand how people are working and implementing analytics initiatives like we've talked about today. Okay, so since we're out of time here, if you have any questions, please don't hesitate to send us a note. We appreciate you guys joining today, and we hope you found it valuable. With that, thanks for joining, and have a great rest of your day.